From a swirling cloud of absolutely nothing to the solid ground beneath our feet, today we're traveling 4.6 billion years back in time. Welcome to The Explainer. We are going to be breaking down the dramatic, chaotic, and honestly downright fascinating science of exactly how our planet came to be.
So how exactly does a cloud of cosmic dust become a living planet? It sounds almost like magic, doesn't it? Just think about it for a second. You are currently sitting on a giant sphere of rock, hurtling through space, completely surrounded by oceans and an atmosphere that breathes life into literally everything. Yet if we rewind the clock far enough, absolutely none of this existed. Today, we're going to break down this 4.6 billion-year-old process and solve this incredible mystery step by step. Let's kick things off with part 1. The cosmic snowball idea, an everyday analogy. Imagine you're out making a snowball. You aren't starting with a solid block of ice, right? You're taking tiny, individual snowflakes and pushing them together until they stick. You roll that clump around in the snow, and small pieces become bigger pieces until eventually you've got a giant sphere. Well, Earth formed using this exact same mechanical principle. The universe just swapped out the snow for cosmic dust and rock. It's the simple idea of tiny pieces sticking together to build something massive. Moving on to part 2, ignition of the solar system, the cloud and the sun. 4.6 billion years ago. I mean, just let that number sink in. To put that unfathomable amount of time into perspective, our entire human history is barely a blink of an eye compared to this era. Back then, there was no Earth, no Mars, not even the sun. There was just a freezing, giant cloud of gas, dust, and ice floating out there in the dark. We actually call this massive cosmic cloud a solar nebula. And for a really long time, it just sat there, dormant. But then a disturbance happened. Scientists think it was likely a massive shockwave from a nearby exploding star, a supernova, that triggered a chain reaction. That shockwave caused the cloud to begin collapsing inward under the immense weight of its own gravity. The Great Gathering had officially begun. As gravity pulled everything inward, the vast majority of that material gathered right in the center. With all this gas and dust getting crammed together in one spot, the pressure skyrocketed, temperatures hit millions of degrees, and suddenly, nuclear fusion ignited. Boom, the sun was born. But here's the crucial part. Not all of the material fell into the new sun. A massive spinning disk of leftover gas and dust stayed behind, swirling around it. And that spinning disk? That became our cosmic construction zone. Which brings us to part 3, forging a magma ball, accretion and early Earth. Inside that spinning disk of leftovers, tiny dust grains started bumping into each other, just like those snowflakes we talked about. They stuck together to become pebbles, then rocks, and eventually, these massive mountain-sized bodies flying through space that we call planetesimals. Through a process called accretion, their growing gravity acted almost like a giant cosmic vacuum cleaner, pulling in absolutely everything in their path, allowing them to grow larger and larger. Now, the result of all that violent accretion was, frankly, a total nightmare of a young planet. Because of the constant violent collisions, the intense compression from gravity, and the heat from radioactive decay, early Earth was just a giant, boiling magma ball, pelted relentlessly by asteroids. It's actually staggering to realize that our modern world, with its cool crust, the deep oceans, the breathable air, started out as a raging sphere of liquid fire. Let's dive into part 4. Heavy impacts and layers, shaping Earth and the Moon. Because the early Earth was entirely molten, a process called planetary differentiation took place. Basically, the heaviest elements, metals like iron and nickel, sank all the way down to the center. That actually created a core that, today, is as hot as the surface of the sun. Meanwhile, the lighter, rocky materials just floated to the top. This sorting process is exactly what gave us our distinct core, mantle, and crust, and it even forged the magnetic field that protects us from deadly solar winds right now. But the early solar system definitely wasn't done throwing curveballs. This brings us to what scientists call the giant impact hypothesis. Imagine a rogue, Mars-sized object named Theia slamming directly into our young planet. The collision was so unimaginably violent that it effectively liquefied both bodies and blasted billions of tons of debris straight into orbit. Through that same process of accretion, that debris ring clumped together to form our moon. So every single time you look up at the night sky, you're literally witnessing the aftermath of the solar system's ultimate hit and run. Moving into the final stretch with part 5, the big cool down, setting the stage for life. Eventually, as the asteroid bombardment slowed down, the Earth's crust finally began to solidify.
Deep within the planet, volcanoes were spewing massive amounts of water vapor and gas, building up our very first early atmosphere. And then the temperature dropped just enough for all that vapor to condense. It began to rain, and we aren't talking about a light drizzle here. It rained relentlessly for millions of years. This epic downpour filled up the rocky basins across the planet, creating the very first oceans. After all that chaos, the stage for life was finally set. Looking back at this entire 4.6 billion year timeline, it really just boils down to 5 main stages, all driven by a single powerful engine: gravity. Microscopic dust became rocks, those rocks accreted into planetesimals, those massive chunks smashed together to form a molten protoplanet, which, at long last, cooled down into the incredible Earth we know today. Every rock, mountain, ocean, and living thing on Earth traces its origin back to a cloud of cosmic dust that existed 4.6 billion years ago. That includes the water you drink and the very cells in your body. We are fundamentally, literally, built from the cosmos. But, it leaves us with one final fascinating question to ponder. If gravity and space dust built our incredible world here, how many billions of other worlds are currently being forged in the dark exactly the same way? Thank you so much for joining me on this explainer, and I'll catch you in the next one.